All right, here are some example problems from plane sections of three-dimensional figures. Number one, which types of triangles can be formed by taking the cross-section of a rectangular prism like the one shown above? So what type of triangles could we make if we cut this rectangular prism, it's basically just a box, in all these different ways with a flat plane? So could we make an isosceles and scalene triangles, equilateral and isosceles only, all three, or no triangles can be formed? And the answer is you can make all three. When you are putting together a cross section through a rectangular prism, just imagine this was a rectangular cake and you could slice it in any way you wanted. Well, if you wanted to make an equilateral triangle, you would just have to make sure that your slice was equidistant from one of the corners in all sections. So let's say you put your knife blade exactly halfway from here to here. And let's say that was, 2 inches. Well, as long as the knife blade goes through this edge at 2 inches and this edge at 2 inches, then you're going to have an equilateral triangle. Well, what if you want an isosceles triangle? As long as it goes equidistant from this point on two edges, you'll have an isosceles triangle. Well, what if you want a scalene triangle? All you have to do is make sure that your knife blade goes through this fake cake of ours at three different distances from that corner. And then you're going to get a triangle with three different lengths. So you can make all the triangles. Number two, in the cube shown below, the distance between vertices 2 and 6 is 14 centimeters. So here's vertex number 2. Here's vertex number 6. It's saying that that distance is 14 centimeters. But it also says it's a cube. So guess what? All the vertices are 14 centimeters apart, except for the ones that are like diagonal from each other. But 2 to 6 is 14 centimeters, 2 to 3 is 14 centimeters, 3 to 7 is 14 centimeters, 7 to 6 is 14 centimeters, and so on and so forth. If the cube is divided into two equal parts by a plane parallel to the face defined by vertices 2, 3, 6, and 7, what will the area of the cross section? What will be the area of the cross section? So what it means when it says that it's divided into two equal parts by a plane, again, pretend like this is a big cubical cake. It's a cube cake. And the plane that divides it into two sections is your knife blade cutting the cake. When it says that the plane is parallel to the face defined by 2, 3, 6, and 7, this is the face on this side on the right that's defined by vertex 2, vertex 3, vertex 6, and vertex 7. So imagine your knife blade goes parallel to that, so right next to it. In other words, the face that's going to be cut out of it is going to look just like the face 2, 3, 6, and 7. And we already know that the distance from 2 to 6 is 14, which means the distance from 2 to 3 is 14. So the area is going to be 14 times 14, which is 196. Number 3, the rectangular prism above has two congruent square faces. Let's just stop right there. That means that ABCD is a square, and so is EFGH. Those are both squares, and they're the same size. And 4 congruent rectangular faces. That means the 4 rectangles that connect those two square faces we were just talking about, those are all the same size. If the rectangular prism is divided into two equal parts by a plane parallel to face CDHG, which of the following best describes the cross-section of the prism? Well, what is face CDHG? Here's C, D, H, and G. It's a rectangle, right? So a plane that is parallel to that will also be a rectangle. Which one of these looks like a rectangle? W. All right, so from the last two problems, what you should have gathered is if you have a shape and then you have a plane that is parallel to one of the faces in that shape, then the cross section will be the same shape as the side that it was parallel to. In our last one, we had a square cross section because our plane that made the cross section was parallel to a square face. And in this one, our cross section is a rectangle because our plane was parallel to a rectangular face. So W is the answer. Number 4, if the rectangular pyramid shown above is sliced by a plane parallel to the two longer sides of the base and passing through the top vertex, which of the following best describes the cross section of the pyramid? So this time it goes through the very tip top of the pyramid. So imagine you're cutting this cake and you cut right through the very top of it. And then the plane goes parallel to the two longer sides. So straight down through the middle of this, cutting it into two halves long ways. So imagine the knife blade goes all the way down to the bottom and it cuts right through the middle right there. Now, this is a good time to mention that you should be going through the lessons on these and keeping track of them, because there are a lot of good examples here and they're drawn out and they have pictures that you might be able to see a little bit more easily. And a couple of these have triangular and rectangular prisms that have planes cutting through them, like example number 3 here on page 3. This looks just like the problem we're dealing with. Imagine that this gray triangle is what we're talking about in the problem that number 4 that we're on right now. In this example number 3, this is a cross section with a plane that is parallel to the long side of the rectangular base and goes right through the tip top of the pyramid. So this is the kind of shape you're talking about. You can see that it would go, one side of the triangle would go down the long side of the pyramid, one side of the triangle would go down the other side of the pyramid, and then one side of the triangle is the base, the very bottom of the pyramid. That's what it would look like. So there's the cross section for a problem just like the one we're working on. Use the lessons, watch them. And there's also a helpful video that you can watch as well if this video isn't doing it for you. So let's go back to our question here. What is the triangle? Well, it's not going to be this one. This is a very this is going to be a very equilateral triangle, and it may be here. This one's very, very skinny. So the long side is the one that it's parallel to. So the base should be long. Is this base real long or real short? It's real short. So this is a better one. It's not going to be W. It's not going to be Y. We're not looking for a square or rectangle. We're definitely looking for a triangle. And so we have to decide, is it going to be this one or is it going to be this one? And since the cross section is parallel to the long side, that means the base will be long as well and not so short and small like that. So X is our answer. Number 5, a cube is shown below. The cross section parallel to the front face of the cube has an area of 121 square units. So the front face is ABCD. That has an area of 121. Well, it's a cube, which means that front face is a square. So for it to have an area of 121, each side has to be the square root of 121. What number times itself is 121? 11. 11 times 11 is 121. So that means AB is 11 and BC is 11, CD is 11, and AD is 11. Based on the given cube, draw the cross section on the grid provided. Use the point provided as one of the corners of the cross section. So they already gave that there. We have to make it 11 long, so I'll go from 1 to 12. It should be 11. And I'll just keep finishing that off. It has to be 11 sections long. So there we go. Next up, number 6. If a plane slices a cube through 3 points, okay, it's only slicing it through 3 points, not 4, 3. 3 points that are equidistant from one of the vertices, which of the following best describes the cross section? Well, if it goes equidistant through 3 points, that means that each of those 3 points have to be equidistant from each other, and that is Y. Not Z, because these 2 points are farther away than these 2 points. So it went through 3 points, so it has to be a triangle. And if it went through 3 points that are equidistant from each other, that creates an equilateral triangle. And again, you have examples of these. You see if I can find one in your lesson. If you're having trouble drawing it, here we go. Well, that one's not equidistant, but it's close. If you have a cross section going through a rectangular prism like this, here it's going through 3 points, point Q, point N, and point S. And so you can kind of see it creates a triangle there, right? So just imagine that point Q and point N were the same, and this is the vertex they'd be equidistant from. In this particular diagram, they're not equidistant, but imagine that Q and N and S are all the same distance away from R. That's what equidistant means. It means they're the same distance away. So if Q, S, and N, in this example, were all the same distance away from R, then wouldn't this triangle that we ended up with be an equilateral triangle where all the sides are the same distance away from each other? And the answer is yes. So we're looking for Y. Number 7, if the square pyramid shown above is sliced by a plane parallel to the base, we'll stop right there. We already covered that if you slice some three-dimensional shape, and that slice is parallel. Okay, it's a plane parallel to any side, then the cross section takes on the same shape as the side it's parallel to. So the base, what shape is that? It says it's a square pyramid, so that means the base is a square. So the cross section that's parallel to it will also be a square. That's answer Y again. Y is the square. So that's something you really got to take away from this. Anytime that you slice a shape with a plane that is parallel to a face of that shape, the cross section takes on the same shape as the section it's parallel to. Okay. When it's a pyramid, it may not be the exact same size. It'll be a similar shape, but it'll be a square if it's a square, a rectangle if it's a rectangle, a triangle if it's a triangle, etc., etc. Okay. Number 8, if the cube shown below is sliced by a plane to create a triangle, which sets of vertices would the plane pass through? So we have to pass through vertices that make a triangle. Okay, so the cube shown above is sliced by a plane to create a triangle. So let's look at these and see which ones of these sections would make triangles. Let's look at A. First one, 1, 3, and 4. So imagine you go from 1 to 3 to 4. See how those are all at the top there? If I made a plane that sliced through those, wouldn't that also go through 2? Yeah, because 1, 2, 3, and 4 are all on the same plane. So if I put something that goes through 1, 4, and 3 at the same time, it also has to go through 2. That means that cross section is going to go through 4 points, and that would not make a triangle. That would make a square because it's cube. Or if it was a rectangular prism, it would make a rectangle. So it can only go through 3 vertices. Okay, any plane that goes through 1, 3, and 4 would also go through 2. So A is automatically out. B, start with 4, 5, and 7. Got 4, 5, and 7. Okay, yeah, we could put a plane that slices through those 3 points, and those are the only ones that would go through. That would be a triangle. 1, 2, and 7. That also works. 1, 2, and 7. You could put a plane that goes through 1, 2, and 7. But wait, how do you get a plane that goes through 1, 2, and 7 and not 8? Can you picture that? A slice going through 1 and 2, so it has to go right along this edge, and then down straight to 7. Wouldn't it have to go through 8 as well? And the answer is yes. So you can make 1, 2, and 7 work, but not without 8. And if it goes through 8 as well, that's another 4th point, and that doesn't make it a triangle. That makes it another cube, okay, or another square, I should say, from the cube. Let's try C. 3, 5, and 8. Okay, 3, 5, and 8. Could we slice through 3, 5, and 8? Well, we can go through 5 and 8. It would go right along that edge right there, 5 and 8. And then if I go diagonally up to 3, I can do that. But can I do it without also going through 2 at the same time? And the answer is no. So that's another time I would have to go through 4 points. And if you go through 4 vertices, then you're going to end up with a quadrilateral. It better be D. Let's go through the very first one here, 4, 5, and 7. 4, 5, and 7. Yep, that works. Just like on B, we can slice through 4, 5, and 7, and we're not forced to go through any other vertex to get there. 1, 3, and 8. Okay, 1, 3, and 8. Yeah, again, we could take a slice, a line right from 1 to 3, and then take it straight down through 8 and not have to go through anything else. Again, imagine like you have a knife blade and you're cutting a cake. You could cut the cake right through 8 and not have to go through 5 or 7 or 6 or anything like that. And then finally 2, 4, and 7. Yes, again, you could line your knife blade right up across the diagonal 2 and 4, and then slice downwards away from the other vertices right to 7, and that would again create a triangle. So D is our answer for that one. Number 9, consider the given rectangular prism. The cross section perpendicular to the base and parallel to the front of the given rectangular prism has an area of what square inches and a perimeter of what inches. Okay, so this cross section is perpendicular to the base. All right, perpendicular to the base means it goes straight down to it, hits it at a 90-degree angle. So the front of this also does the same thing, and our cross section is parallel to the front. So in other words, our cross section is the exact same dimensions as the front of this rectangular prism. So what are the dimensions of the rectangular prism that's the front of this? We know it's 7 inches long because the rectangular prism is 7 inches long, and we know it's 5 inches high. So what's 7 times 5? 35. And what's the perimeter? 7 plus 5 is 12. 12 times 2 is 24. Okay, or if you'd like to do 7 plus 7 is 14, and 5 plus 5 is 10. 14 plus 10 is 24. So that works out as well. So again, this cross section is parallel to the front of this rectangular prism, so it's going to take on the same shape as the front of the rectangular prism. Number 10. In the rectangular prism shown above, the distance between vertices A and H is 6 centimeters. The distance between vertices A and B is 10 centimeters. And the distance between vertices A and E is 4 centimeters. If the rectangular prism is divided into two parts by a plane that passes through edges AB and HG, what will be the area of the resulting cross section? So again, you have to take a look at the details for what it says. The plane passes through the edge AB and HG. Okay, let's look at the edges AB and HG and see where they are. The edge AB is all the way up here, A to B, and the edge HG is diagonal away from it. So our plane is going to cut from AB on the top down diagonally through this box and intersect with edge HG here. Okay, so now we could go back and we can look at our measurements that they gave us. The distance between vertices A and H, which is one part of our cross section, isn't it, is 6. So our cross section is going to have an edge that is 6 centimeters. The distance between the vertices A and B is 10 centimeters. Well, that was where our cross section started, so that's another edge of our cross section. Our cross section is going to be a rectangle because it goes through 4 vertices. Okay, so it's going to be a quadrilateral. AB is 10, so that's one side of the rectangle that is our cross section. And AH is 6, and that's another edge of our cross section. The distance between vertices A and E is 4 centimeters. Well, I don't need to know that. That is useless information because that's not part of our rectangle. Our rectangle goes from A to H, which is 6, and A to B, which is 10, and then B to G, but that's the same as A to H, and H to G, but that's the same as A to B. So it's going to be a 6 by 10 rectangle. So what would the area of the resulting cross section be? 6 by 10 rectangle is 6 times 10, which is 60. All right, so I know this one's going to be a little tough one. Don't be too hard on yourself if you're having trouble kind of seeing the cross sections on these. The best advice I can give you is carefully go through these examples. There's lots of written examples for a reason, and there's a video for you to watch at the end of this that is also well made. And then just try these out. Go through it a few times if you have to. And if you have any particular questions at all, reach out for help, and good luck. Work hard.